Hey, sixth graders, we are looking at our triangle theorems today, and we are going to be using the foldable that we've set up. If you don't have the foldable, that's okay. Just go ahead and put this into the next free page in your math journal anyways. So this is what the front cover of your foldable should look like. So obviously here we have three theorems that we're going to go over. We have the triangle inequality theorem. The rule for this one is about the lengths of the sides. Then we have the triangle sum theorem. The rule for this one is about the measures of the angles. And then the last one is called the opposite side angle theorem. And this rule is about the sides compared to the angles. So if you're ever looking at a question and let's say it's about the lengths of the sides, you know that that's either going to be our triangle inequality theorem or our opposite side angle theorem. So this just kind of helps you figure out which rule you need to look at. We'll practice lots with these and you'll get them down. Okay, let's flip to the inside. Okay, our first one here, our top one, is the triangle inequality theorem. And our little blurb that we glued in, or that you may have to write in if you don't have this, over here it says, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And so we'll look at an example over here on the right side so that you understand what that means. So the first one that they gave us over here has triangle STU. And it's just called STU because you kind of name it by the letters that they give you. Now, this is telling us that the length of any two of our sides is bigger than the third side. So this first one here, it says that the length of ST, which is right here, the length of this side, plus the length of this side, has to be bigger than this third side over here. And that's what this first one said. So ST plus TU, that's just the line, is greater than SU. So, and each of these, TU plus SU is greater than ST, SU plus ST is greater than TU. And now we'll look at an example over here of one that actually has the lengths on it so you can kind of get what this is saying. We'll name this one triangle ABC. So now what this one is saying is that any two sides of this have to be bigger than the third. So let's say we start out with, I'll circle this in blue. Let's say we start out with line AB, which is 5, and we're going to add it to this small one over here. So we're going to take 5 plus 3, which is 8, and that has to be greater than the fourth side, which is 4. So 5 plus 3 we just said is 8, and 8 is greater than 4. So that theorem is just showing that those two sides are bigger than the last one. So another one here, we could pick a different one. I'll use green now. Let's say we took these two. I'm going to take line AC, which is 4, and line CB, which is 3. So I'm going to take 4 plus 3, and that has to be greater than 5, which is the third side. Well, 4 plus 3 is 7, and 7 is greater than 5. So it worked again. So two sides have to be greater than the third side. Any two, whichever two that you pick. Okay, that's our first theorem. Our next one down here, this middle one, is our triangle sum theorem. So this one is kind of the shortest and easiest to remember, and it is the sum of the measures of the angles in a triangle is 180, and there are always 3 angles because there's 3 corners. So the sum of the 3 angles is going to be exactly 180 degrees. It can't be any more, it can't be any less, it's got to be exact. So now let's look over here at an example, the one that we kind of cut out that was already done over here. It is saying that angle A plus angle B plus angle C equals 180. So when we add all 3 of them together. So now over here I have 2 examples. You'll see this one is 70 degrees, this one is 85, and this one is 25. We are simply going to add all 3 of those together And when we add them together, they equal 180 degrees. If they don't equal 180 degrees, then we've done something wrong because they have to be 180. Now, most of the time when you have a problem of this, they're not going to give you all three of the sides like this, or I'm sorry, all three of the angles. They're going to have a missing one that has an X in its place, and we kind of have to solve and figure it out. So now let's look at this second one here. It has a right angle, which we know is 90 degrees. So if they ever have this box, you just fill it in and say, oh, this is 90. Now we're going to add the two that we have. So we have 45, and we know that the little box one down here is 90. So 45 plus 90 equals 135. And I still have to figure out what this last one is. Well, if I know all of the angles have to add up to be 180, I can do 180 minus what I already have for my other two sides, which is 135. And that's going to give me my third corner. So let's do a little bit of subtraction here. I'm going to have to borrow 10 take away 5 is 5. 7 take away 3 is 4. And 1 is 0. So we get that this third side is 45 degrees also. So by subtracting and figuring out what we have total, we can also always figure out a third missing angle, because we know that they add up to be 180. Now, our last one. Our last one seems really complicated when I read this first definition, but once I show you, you're going to be like, oh, that makes sense. Okay, so this one is our opposite side angle theorem. This one says, if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So, I know that sounds like Spanish right now. Let's look over at an example. Over here, we're going to first look at the lengths of the sides. So, I'm going to circle those all with the same color. So, we'll look at this, this, and this. If I pick out the biggest side of these three, we might have to do a little bit of math, because obviously this one's not the biggest because it's 1 3 something. But these two are both 2. So we have 2 5/8 and 2 3/4. We have to figure out which one is bigger, so we might have to do a little math. We might also be able to figure out, well, 2 6/8 would be the same as 2 3/4. So therefore, this one is actually going to be smaller. But you might have to do a little math to figure that out. So once I figure out, okay, 2 3/4 is my biggest side. This has to be opposite, which is like across from the largest angle. Well, my angles are 81, 70, and 29. So since this is my biggest side, it has to be across from my biggest angle of the three. Same thing for smallest side and angle. I will use, what happened? I used green. My smallest side, we just said was, let me erase it. We just said it was this 1 3/8 one. So I'm going to circle that in green. This is my smallest side. It has to be across from my smallest angle. Well, 29 is the smallest. So you always just look across, and the angle and the side that are opposite have to match. They either both have to be the smallest or both the biggest, and then obviously the other one is just our one in the middle. But those two have to match. Smallest across from smallest, biggest across from biggest. And we'll work with some problems that kind of test us on this also in class. But I just wanted to make sure you have the notes first. Once you have all of this in 6th graders, this is all you need for right now so that we can practice these when I get back next time in class. So thank you for getting your notes done. I appreciate it. Adios. I will see you soon.